Hello, 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 everybody. Hello, Narvirandariki. Hi, 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 hi. Hi, hi, hi. Good evening, good evening, good evening. Hey, good evening, good night, sir. Sir, you're not even letting us sleep. Okay. Hello, Narvirandariki. Okasari cheppandi. Okay. Okay. Hey, I'm really sorry to schedule the lecture at this time. Kani, the lecture, the, the chapter in this lecture, good evening, all of you, good evening, is properties of solids. Ante idi chinna chapter ante it will be completed in 2 hours or something, okay? Somewhere around 2 hours or even less than that. Chuddam. If possible, we will complete it in less than 2 hours. లేదంటే 2 hours is the expected time. చూసుకోండి. Okay. How is everyone doing? చెప్పండి ఒకసారి. Okay, all of you. So, the name of the chapter is properties లేదా మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్ కదా. ఎస్, ఎందుకంటే మీకు రెండు వేరే చాప్టర్స్ ఉన్నాయి. థర్మల్ ప్రాపర్టీస్ ఆఫ్ మ్యాటర్ అండ్ మెకానికల్ ప్రాపర్టీస్ ఆఫ్ మ్యాటర్. ఈ చాప్టర్ మెకానికల్ ప్రాపర్టీస్ ఆఫ్ మ్యాటర్ వి ఆల్సో కాల్ ఇట్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్. ఓకే, డ్యూరేషన్ విల్ బి ఫర్ 2 hours. Who is it? Nagalakshmi, 2 hours. Okay, 2 hours. It will be completed by 12:30 or something like. చూసుకోండి. So you can simply say, sir, the name of the chapter is mechanical properties okay. దాని తర్వాత there is only one single chapter left from your mechanics, and that is fluids. Properties of fluids రా. అదే ఒకసారి your fluids has been completed అంటే your entire mechanics has been completed. చూసుకోండి. Physics లో there are these two giants. First one is your mechanics. Are you understanding? And దాని తర్వాత the biggest giant is your electrodynamics. Okay, the biggest giants, these are the two. If you are good with these two, and there is it should be little touch of modern physics ra ade. So if you are good with these three branches, you can at least score 140 to 160 easily. Okay, easily 140. 140 is the easiest score that you can achieve. Understanding. Most of the teachers, what they do is they take entire year of your first year లేదా your class 11th only in teaching mechanics. అర్థమైంది? And your second year they will start with your electrodynamics and remaining topics. Okay? Yes. Hi Isha. Hi. How are you, Isha? Fine. Okay. Hello rabbit. Hello. Don't know. Yes. So ఈ chapter లో we'll be talking about mechanical properties. 16 people. Oh, good. Mechanical properties of solids kada. Yes. So yes, Rohit, yes, it is super 45 series. One shot ante super 45. గుర్తుపెట్టుకోండి. ఇక్కడ నుంచి whatever the lectures we are gonna take, they will be just considered under your super 45. Okay, Spandana, it's okay. Yeah, I'm fine, Isha, I'm fine. చూసుకోండి. The first terminology that I want to discuss with you is elasticity. Elasticity ante entira? What do you mean by elasticity? What do you mean by elasticity? Nagalakshmi, you can ask your doubts on Telegram, okay? Please join the Telegram channel, all of you. ఏదైనా doubts ఉంటే you can reach out at టెలిగ్రామ్ అందరికి. హాయ్ 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 హాయ్. చూసుకో, ఎలాస్టిసిటీ అంటే ఏంటిరా? ఎలాస్టిసిటీ అంటే we are just gonna see elasticity, coefficient of elasticity is in this chapter, okay? So నా దగ్గర ఒక సాలిడ్ ఉంటే I will do something, I will do deformations on this solid and I will try to break it, I will try to pull it, I will try to push it and all these things, okay? Okay, Harshita, got it. Okay, got it. టెలిగ్రామ్ లో మీరు సర్చ్ ఫర్ వెదంతు తెలుగు నీట్, అదే, ఓకే. యూ కెన్ సర్చ్ ఫర్ వేదాంతు తెలుగు నీట్, విల్ గెట్ అ ఛానల్. ఆ ఛానల్లో జాయిన్ చేసుకోండి. ఏక్యూ సర్ అనేది దెర్ ఇస్ అన్ అకౌంట్. దట్ ఏక్యూ సర్ ఈస్ ద పర్సన్ దట్ ఈస్ స్టాండింగ్ ఇన్ ఫ్రంట్ ఆఫ్ యూ, ఓకే. Okay, the ability of a material to deform under a force and return to its original shape. Perfect definition, okay. Kani it does not give the feel ra. Feel ante asal ledu. Okay, I can't tell you that, okay. Can't tell you. The deep teaching is not required for your NEET examinations. Chuskondi. Elasticity, you can simply say elasticity is nothing but tendency to regain the shape ra. Ade ante entira, you have a rod, sir. మీ దగ్గర ఒక rod అంటే తెలుసా? Yes, you have the rod. ఇప్పుడు what you are doing is you are pulling this rod ray from both the ends. Try to understand, okay. ఇదే నీ ఫోర్స్ F, ఇక్కడ కూడా you are applying the force F. You are trying to pull it. Are you understanding? Sir, what are you talking, sir? When we are trying to pull a rod, it will not even change a slight of it. Are you understanding? Huh? Good evening. Okay. What I'm telling to you is, if you have a rod, మీ దగ్గర ఒక rod ఉంటే, I don't have a rod actually. Do we have a rod? No, we don't have a rod actually. Okay. You assume this to be a rod, okay? For now, okay, good. I do have. Okay. So ఇదే మీ rod కదా? Yes, it's a steel rod, okay? It's a steel rod, all of you. It's a steel rod, okay? So if this is your rod, I am trying to push it, Ray. Hey, I'm trying to push it. Do you think I will able to elongate it? Do you think the length will increase, Ra? Huh? Do you think the length is going to increase? No, sir. Then why we are talking about all this nonsense? No, go not. Its chapter is a small chapter, right? So you will not need much time for this to complete. Okay. Chuskondi. So if I am pulling this rod like this, Ra, లేదంటే you can assume this bottle only, okay. చూసుకోండి. So if this is my rod and I'm trying to pull it, okay, I'm trying to pull it like this, okay. Do you think it will get elongated? Do you think it will get elongated, Ra? లేదా if you are pushing this rod something like this, do you think it will get shrink or compressed? Ra? Hey, what happened to you, Ray? Why you guys are not responding? Huh? Cheppandi andariki. Do you think the rod will get elongated or compressed? Hello. Yeah. So, in case lo, you cannot say that your rod is getting elongated. Are you understanding? But. When we are discussing physics, we don't consider about chinna forces. Ante enti sir, humanly. Who said humanly, Ra? Bring your hydraulic press. Okay, bring your hydraulic press. Bring your, yes, Rohit, yes. Idi episode. Yeah. It is useful. Bring your hydraulic press, and you try to elongate it. Now it will elongate. Ade kada. Physics lo, we will not talk about human barriers. Ante human limitations gurinchi we don't talk about it. Are you understanding? Yes. Okay, sir. But still I am not getting the feel of it. Sir. Okay. For now, you remember the definition of elasticity. Elasticity ante entira? Elasticity is the tendency to regain the shape. Are you understanding? Elasticity is nothing but the tendency to regain the shape. I hope you are understanding that. Hydraulic press. You don't know about hydraulic press, ra? You don't know about hydraulic press. Okay? ఒకసారి search చేసుకోండి యూట్యూబ్లో. You go to YouTube and talk about hydraulic press. లేదంటే we'll be talking about fluid mechanics. Okay? ఆ చాప్టర్లో I will tell you something known as hydraulic press. Okay? Hydraulic press. చూసుకోండి రా. Let us talk about some real life instances. లేదంటే you imagine something like this రా. చూసుకో. మీ దగ్గర ఒక స్ప్రింగ్ ఉంటుంది రా. Now sir, we will understand something. Earlier you were taking the rod is not getting elongated or compressed at all, and you are talking about elasticity of that rod. Okay? You are talking about elasticity of that rod. So, ippudu we are taking this spring and we are trying to elongate that spring. Ade kada. Yes, that is the biggest misunderstanding that 90% of the students do have. What is the misunderstanding, sir? The rod is not getting elongated at all. Mari, what is the point to tell regain the shape, sir? Okay, if the rod is elongating, then we are releasing, then it is compressing. Something would mean ra. Kani case lo asalu elongate avadu kada. Are you understanding? Then how can you talk about your elasticity? Good. Very good observation. Okay? Very good observation. If you are having this doubt in the first time, ante you are going on the right track while studying this chapter. Choose. Okay. I am understanding your thoughts. Now, I am trying to tell you with the help of a spring. Okay? Sir, tendency to regain the shape ante enti ra? Regain ante enti? Now focus on the words. Okay? Focus on the words. This is a little theoretical chapter. Okay? Chinna theoretical topics untundi. Right? Yeah. So regain ante enti ra? What do you mean by regain the shape? What do you mean by regaining the shape? Cheppandi andariki. What is meant by regaining the shape? No. Go not. Heat is a different topic. We are not talking about heat into it. Okay? We are only talking about the external forces applied by the people. Yes, it will extend, it will expand, it will elongate. If you heat it, in case slow, we are not talking about heat and all this. Okay? We are talking only about humanly efforts. Okay. Yes, very good. Deforming ante coming back to the original shape or size. Coming back ante entira? Why are we using coming back? Ante what could have happened before it? Cheppandi. I just want to know the flow. Okay, naku just flow kavali ra. Okay, so this was the spring. Good. Sir, we have applied some force from the external side. Ante ide na external force F, and here also this is my external force F. Ardhamaindi? Now what is happening? Cheppandi andariki. What is happening ra? Sir, if you are applying some force and the shape is changing. Shape is changing. Yes. So, can I say that this force is a deforming force ra? It is changing the shape kada. Deforming. It is deforming the object. Ante at the first place, you first applied a deforming force ra. Flow gurtu pettukondi. Applied a deforming force. Okay, sir. Naku ardhamaindi. Idi the first step that we did. Deforming force. Dan tarvata ఏమైంది చెప్పండి. No. Okay. Dan tarvata there was a deformation in the object. ఇదే కదా? Yes. This is a step number 2 ra. Dan tarvata there was a deformation in the object. ఇదే కదా? Yes. Dan tarvata there was a deformation in the object. Okay, sir. What after that? Hey, what after that, ra? What after that? What after the deformation? Cheppandi. I'm only talking about this spring case, okay? So I just want about this spring. Cheppandi. Initially, you applied a deforming force. Dan tarvata the shape got deformed. After that, what happens, ra? What happens? Step number 3. Cheppandi. Step number 3. Let us see how many of you can give me the right answer. Okay, Cheppandi. How many of you can give me the right answer? Sir, first I applied deforming force. Dan tarvata deformation aindi. Ee deformation tarvata emaindi cheppandi. After this deformation, can I say that it will come back to original position? Ante it will come back to original position. Ade kada? Ide kada? Yes. Okay, ante it regains the shape, ra. It regains the shape. Are you understanding? This is wrong. Actually, I should not say wrong, but it is wrong. It is wrong. It does not happen immediately, ra. It is the 4th step. Andariki chudandi. That's what I'm telling to you. This chapter is a little theoretical, okay? So you have to remember some theoretical things. So it is point number 4 actually. Point number 3 is different, ra. Chuskondi andariki. As soon as the deformation happens, there will be a restoring force that will be developed in the spring, ra. Chudo andariki. You applied the force, the shape got deformed, ra. Andariki chuskondi, okay? This is a deformed shape of the spring. Ide kada? Yes. Now, when you compress it, what happens is there will be a development of a restoring force. And this spring will try to exert a restoring force, ra. Chuskondi. This is my restoring force. Ade kada? Yes. Sir, ikkada kuda this is my F restoring. Step number 1, deforming force came into scenario. Dan tarvata shape deform aindi. Third step lo development of a restoring force happens, ra. It is chala important, okay? Then development of a restoring force. Okay? Development of restoring force. And dan tarvata after that, this restoring force makes this spring regain its shape. Are you understanding? Ardhamaindi kada? No. Okay, what's your name? I forgot it actually. I'm sorry. Okay. Let me just check it. What is your name? Nagalakshmi. I'm sorry, I forgot your name, okay? But anyways, what happens is, at muttam scenario, sir, after deformation, everything, that's a different scenario. I'm just talking about a simple spring case. You take a spring, push it, release it, it comes back. Simple scenario. We're not going into that much of details, ra. We are going into simple things, okay? Simple things. Chusko. Harshita, okay. Harshita. Good. That's the problem. Like if you You're joining with some other names out. I will not remember your names. Okay. Harshit. What did I say? Re? I was telling you something like this. Chuskondi andariki. First of all, you apply a deforming force on the spring. Dan tarvata deformation happens ra. After the deformation has happened, chusko. This flow is very important, very important. First this happens, dan tarvata this, and after that this, after that this. Are you understanding the flow? Okay. Sir, why did you write it with a different color? And it is an important thing for me. It is chala important thing. Okay, chuskondi. Now I am telling you two different terminologies. Andariki jagrataga vinandi. Ippudu I am talking to you regarding two different terminologies. First one is your stress. Hey. First one is your stress. And the second one is your strain. Okay? They both are different. Okay. Different and different. Okay? Okay. Chapani andariki. Are you understanding? Okay, perfect. So, sir, what is stress and what is strain? Ippudu question you just remember, right? Your stress is nothing but your force upon area, okay? And your strain is nothing but the measure of deformation, okay? Your strain is nothing but the measure of deformation. You try to understand it, okay? You try to understand. I don't know if there are some teachers, what they tell is, this is stress, this is strain. Ante, finished. They'll just give you formula and they'll leave everything. Can I'll not do anything like that, okay? I'll go in detail, Ra. Chusko. Let us go in detail. Sir, flow cheppandi. Modatiga, you applied a deforming force. Dan tarvata deformation aindi kada. Deformation gurunchi, what express your deformation? Your stress or your strain, Ra? Your strain. Ante, whenever your length or your area or your volume has been deformed, we talk about strain. Chusko. So, modatiga, we talk about strain and then we talk about stress. Chuskondi. So, in every deformation scenario, strain comes first. Strain nunchi there comes a rise to the stress. You understand, okay? You understand. It has been asked in the question itself. Strain leads to stress. Are you understanding? Strain leads to stress. Ante entira, whenever you are trying to deform an object, first there will be strain into that object. Strain ante deformation. Dan tarvata there will be stress into that object. Stress ante deformation. No. We will talk about it later on, okay? We will talk about compressive strain, all these things later on. For now, you understand this, okay? You understand now, all of you. This was my metallic rod, okay? Andariki chudandi. This was my metallic rod, okay? This was my metallic rod. You take a hydraulic press. I'm telling you, okay? You might not have heard these things, but I'm going to tell you, okay? You have a metallic rod, solid rod, telsa, cylinder. You take a hydraulic press and try to push it. Are you understanding? Try to push it. Try to compress it. It will compress. It will compress. It will compress. You don't say it will not compress. You understand. What happens is we don't differentiate between that hairline difference. 99% cases, what we do is we push it very strong so that it gets deformed forever. Kani careful ga compress cheste, you will see some miracles into it. Okay? Careful compression leads to some miracles. Chuskondi. When it's a rod and when you are applying a force F ante chala. Are you understanding? It's enough or it is sufficient or it is in that range so that it is just able to deform this rod. So when you apply the force, the shape of the rod changes. Yes, yes, yes. Yes, it changes, right? Changes. No, I'll tell you. Don't worry, okay? Gonad, I'll tell you. So when you compress it, the shape of this rod actually changes, Ra. Yes, it changes. It does change. Andariki. Don't get surprised. It changes, okay? Kani, that shape change will be very small, okay? Very small. Small changes. Choose Kura. This was your force, Kana? Yes. So this was your force. This was your force. And you first applied a deforming force. Sit relaxed. I promise you, by end of this chapter, you take whatever PYQs from NEET, you will be able to solve it. Okay? Okay? Okay, good. Choose. Pranay Suhas. I am teaching a concept. When I am teaching a concept, do you know more than me? Do you know more than Mira? Huh? No. Harshita, Ade, the biggest mistake you guys are doing is the same. Choose one. What I'm telling to you. The biggest mistake you guys are doing the same. You try to understand it, okay? Andariki, I'm telling you the little details, okay? Then listen to me, okay? If you don't know more than me, then listen to me, okay? I'll tell you. Choose one. Step number 1, you applied a deforming force. Ide kada? Yes. So you applied a deforming force. Dan tarvata, what happened, Ra? After the deforming force, there was a deformation. Ide kada? Yes. After the deforming force, there was deformation in the object. Ra. Choose code. Ipudu. All of you. Not able to copy it. Yeah. Anyways, you try to understand, okay? After this deformation, what happened, Ray? What happened? Cheppandi andariki. What happened, sir? After deformation, there was a restoring force developed into the rod. Ante kada? Yes. After the deformation, there was this restoring force developed into the rod. Can you tell me the direction of the restoring force, all of you? Direction of restoring force, Cheppandi. Direction of restoring force is opposite. Ide. So, ide na restoring force, F restoring. Ante kada? Very good. This is my restoring force. Now, let us talk about strain first. Okay? Let us first talk about strain. Cheppandi. Strain ante enti ra? Strain ante enti? Leda. Let me just talk about stress first. Okay? Let us first talk about stress only. Choose. Your stress is nothing but force upon area. What force? What force, Ra? What force? Your stress is nothing but your force upon area. But what force? This force? No. Other. When you write the formula for your stress, it must always be force restoring divided by area. Ante this is your restoring force, and this force divided by area is your stress. People tell me, do you think this restoring force is happening before deformation? Kabatti, your stress is useless before your strain. Modatiga, it must get compressed. Then and only then it will generate that restoring force. Our restoring force divided by area gives me the stress of that object. Okay? Right. You try to understand. Okay? Stress is nothing but restoring force upon area. It's not deforming force by area. That's the biggest misunderstanding. Okay? Stress is equals to deforming force divided by area. It's a wrong interpretation actually, okay? It's a wrong interpretation. Your actual definition of stress should be, Chapandi, stress is equals to restoring force divided by area. But, okay, but. When the object is a rigid object, okay, when it's a rigid body ante entira cheppandi, when it is a rigid body, for a rigid body ante enti, whose position does not change with respect to point, with respect to time ra, and if this is pen, whatever you do, its position, its points, it should remain at the same position. That means there should be no change of position. Ante kada? Yes. Okay, can you say that? Okay, can you say now that strain leads to stress? Endukante strain ante deformation, and deformation nunchi you will get your restoring force, and that restoring force is used in your stress. If it's a rigid body low, you can simply say that, sir, whatever deforming force you are applying, చూసుకోండి, in a rigid body, your deforming force, it is equals to your restoring force. Ante kada? Kabatti, for a rigid body, you can use this formula also, leda this formula also. Endukante both the forces are same. Are you understanding? But if the object is not a rigid object, in that case, you cannot say that these two forces will be equal. Then you will have to use restoring force instead of deforming force. Understanding? Are you understanding? Yes. If the object is non-rigid object, in that scenario, you must say your stress is restoring force upon area. Ante kada? Are you able to understand it? Cheppandi. How many students are watching? Okay. Right. Perfect. Okay. So, now let us talk about stress. Cheppandi, andariki, all of you. Let us try to understand. Okay. Let us say I have the object something like this. Hey, chooskondira. Okay. You have deformed rod. Idi already deformed aindi. Now, restoring forces have to develop inside it. Andariki jagrataga vinandi. It is already deformed object, okay? It is already it is already deformed object. And you already applied a deforming force and you have changed the shape of it. But the restoring forces are acting something like this. So, ide na restoring force ra. Are you understanding? This is my restoring force. Are you understanding? Tell me, stress formula entira? Stress is equals to, cheppu andariki, your stress is equals to restoring force. F, yes. Let us say the area is A. Your area is A. Force upon area A. Ide kada? Force by area A. No. You understand. Whenever you are writing stress, your area has some limitations. Okay? Your area is only the area that is perpendicular to your restoring force. Are you understanding? And this area vector must be resolved now. Choosko. And sir, this is my area vector kada. So it must be resolved in two different forms. Cheppu. So this is your first and this is your second area vector. Ante this area is getting resolved in two different forms ra. So this is your first area and this is your second area. Okay, I think it's visible to you. Are you able to understand? Whatever this area is there ra, a cos theta, చూసుకోండి. If this angle is theta ra, ఈ angle theta ఉంటే this becomes a cos theta. You substitute that value ra, restoring force divided by area perpendicular లేదా restoring force divided by a into cos theta in this scenario. So ఇదే మీ stress. Okay? Stress is not simply equals to force upon area. Stress is restoring force that has developed after the deformation divided by the area that is perpendicular to the restoring force. Are you able to understand? Andariki cheppandi okkasari. Yes. Next, sir, your stress is a tensor quantity. It's not a scalar, it's not a vector, but it is a tensor quantity. Are you able to understand? Andariki cheppandi. Okay, right. So sir, ఇప్పుడు let us talk about types of stress ra. Okay, let us talk about types of stress. But అందరికి జాగ్రత్తగా వినండి. When I come to types of stress, I'm only assuming rigid body. Rigid body అంటే ఏంటిరా? Your restoring force will be equals to your deforming force. అదే కదా? I don't have to tell you repeatedly that it's restoring force. You understand, okay? ఒక rigid body ఉంటే your restoring force is equals to your deformation force. అంతే కదా? So instead of this, I'm only be using this formula, okay? As long as your body is a rigid body, then you can use this formula. And I'll be using only with this formula. Are you understanding? Endukante it's not in our hands, ra. I can change my deforming force. Are you understanding? And automatically your restoring force will be changed. So I'll not be going to restoring force. Jagrataga vinandi, okay? Okay, so types of stress ante meeku moodu rakala stress unnai. The first one is your normal stress. The second one is your shear stress. The third one is your volumetric stress. There is one more name to normal stress. Can anyone of you tell me that one more name? Okay. Longitudinal and else? Perpendicular? No. Normal stress లేదా tensile stress. Have you heard this terminology, Zara? లేదా longitudinal stress. Okay? Okay. Normal stress ante entira? We only talk about normal stress when you have a rod. Okay? Rod ante enti? Your force ante your deforming force. You understand, it's a very important definition. Okay? Your deforming force is applied perpendicular to the surface. Okay? Perpendicular to the surface. And along the length. Are you understanding? Along the length. This is a very important definition. Andariki jagrataga vinandi. So if this is your rod, okay? If this is your rod, where is the length? Sir, this is the length. Horizontal length undi kada? Yes. Okay. Ante ee case lo your deforming force will be applied at the surface perpendicular to the surface, ekkada kuda perpendicular to the surface, but along the length. Are you understanding? This is the length kada. So if the area is A, cheppandi, what will you say ra? Normal stress is equals to F upon E. Kani, again I'm telling you, this F is not the deforming force but the restoring force that will be developed after the deformation. Okay, we don't talk about stress ra, kani rigid body unte the deforming force is equals to the restoring force. Are you understanding? Yes. So let us take a question ra, andariki cheppandi. Okay, all of you give me the answer of question. Find the normal stress. You see it, right? Yes. Whatever it is, you try to understand. Okay, it's a cuboid, right? Okay, it's a cuboid. All of you. Length. Cheppandi. If they have not mentioned as a rigid body, it is rigid body only. Okay, for your syllabus, మీ syllabus కోసం Non-rigid bodies are not there. Okay, it should always be rigid body only. Okay, it will always be rigid body. Cheppandi. If it's a rigid body, what will happen ra? Rigid body unte deformation ayindi ade kada. You are applying deforming force. Due to this deforming force, there will be a deformation in the object. Deformation ante simply compression kada. Yes. So there will be a compression leda deformation in the object. After this deformation or compression, whatever it is there, there will be a restoring force ra, and this restoring force should be equal to your deforming force. Ide kada. It is the third stage we are talking about. Okay, it has been compressed. Now it will going to elongate and regain its original state. Choose what? What is the force? Stress is equals to force ante restoring ante deforming ante 10 divided by area. Which area to take ra? The area that is perpendicular to the force kada. Yes, ante ide. This should be the area. Area is length into width. Kani force is in the Newton. SI unit kada. SI unit unte your length should also be in SI unit. 10 centimeter ante 0.1 meter multiplied by 40 centimeter ante 0.4 meters. Ide kada. So 10 divided by 0.04 ante 1000 by 4. That means 250 Pascal stress is there. Unit of stress is Pascal only. Are you understanding? Good. Next. Let us talk about shear strain. Okay, shear strain. Shear strain ante enti sir? Shear strain lo your force is not applied perpendicular to area. Are you understanding? Ante enti ra? If this is your, what should I take? Cube? Leda? Yeah, let us take cube only. Okay. Ledante you can take rod also, but that does not keep any significance. Okay, let us say this is your cube. Okay, andarki chuskondi. It is placed on a ground, and your force is applied something like this. Chuskondi andarki. Your force is applied something like this. Ide me force ra. Are you able to understand? I can't even tell you, okay. This is your book kada. Yes, your force is applied something like this. Chuskondi. Something like this. Okay, something like this. Ante the layers are slipping kada. You see this shape, this shape. Okay, the shape over here, this shape. When you are applying a force, what is happening? Cross, tilt. Okay, tilt. No. Only perpendicular area kada. Yes. So your force, after some time, koncham samayam tarvada, the shape is happening something like this. Can you visualize, ra? Can you visualize? Yes. Are you able to understand? This entire force is acting parallel to the surface, not perpendicular, ra. Okay? Parallel to the surface. Ippudu chudandi. If the upper surface has area A, only upper surface, okay, I am talking about upper surface only. Shear stress law, we only talk about force that is parallel to the surface and the surface that is parallel, ra. Choose one. So here the area is A, your force is F. Cheppandi, your shear stress is equals to your force that is parallel to the surface. Ide kada? Yes. Your force that is parallel to the surface divided by area. Which area, sir? The area that is parallel to the surface. Ade. Okay, right. Let us take a question, Ram. I'm trying to merge both the questions. Okay, I'm trying to merge both the questions. Andariki chudandi. right? Yes. Is it a cube? Oh, it's a cube, right? Perfect, perfect. So what I'm doing now is try to understand. Okay, Jagrataga Vinay. It's a very good question actually. So this is your ground. Okay, something like this. Okay, your x-axis, y-axis, and z-axis. It is placed something like this. Okay, this cube has been placed. Each and every side of this cube is 10 meters. Okay, 10 meters. 10 meters. Andariki. Idi kuda 10 meters. And this also 10 meters. Okay, but I am applying a force something like this. Jagrataga vinandi. So this is my force. Ante it is making an angle of 45 degrees లేదా 30 degrees. Okay, it is making an angle of 30 degrees with the vertical, and the value of F is equals to 100 Newton. The question is find shear stress and longitudinal stress లేదా నార్మల్ స్ట్రెస్ ఏదైనా తీసుకోవచ్చు. How many of you can try? చెప్పండి. How many of you can tell me the answers? Okay, let us see. Okay, let us try to understand. You try to understand. Okay, now I am resolving this force, sir. The first force, whatever it's there, it will be straight perpendicular to the space kada, and the second force will be something like this. Values cheppandi ra. 100 cos 30 ante 50 root 3 directly rastunnam, and here 100 sin 30 ante 50 ide kada. Yes, now you can wipe out the entire system. Andariki chuskondi. Okay, now all of you try to understand what I'm telling. So sir, whatever this force was here, the first component is 50 root 3 like this, and the second component is parallel to it ante 50 Newton. Ardhamaindi? This was your components of the forces. So sir, this 50 root 3, it is perpendicular to the surface and it will generate your longitudinal stress. Ardhamaindi kada? Yes. So your longitudinal stress is equals to, cheppandi andariki. Longitudinal stress is equals to perpendicular force ra enta 50 root 3. Ippudu cheppandi jagrataga. I'm not telling that this is the external force. After you applied the force, there will be a deformation. ఈ deformation తర్వాత there will be restoring forces opposite, కానీ this restoring force will be 50 root 3. కాబట్టి I'm taking this 50 root 3 only. Okay, 50 root 3 divided by area ఎంత రా? this is 10, this is 10 ante side square is simply 100 ante root 3 by 2 Pascal. Very good. Okay. What about shear stress, sir? So shear stress is equals to other force ra. Cheppu, what is the shear force ra? Shear stress ante the parallel force. Parallel force is 50 only divided by area is malli okasari 100 kada. So it is 1 by 2 Pascal. Ade. So this was your longitudinal stress. This was your shear stress. Very good. Okay. Very good. Next, let us talk about volumetric stress. Okay. Volumetric stress. జాగ్రత్తగా వినండి. వాల్యూమెట్రిక్ స్ట్రెస్ అంటే ఏంటి సార్? వాల్యూమెట్రిక్ స్ట్రెస్ is not possible by humans రా. హ్యూమన్స్ అంటే you can pull it, you can't push it, you can generate your longitudinal stress, you can generate your shear stress, కానీ when it comes to volumetric stress we can't do. ఎందుకంటే whatever volume is there we have to apply same amount of force at each and every point of that volume. So we don't do all these things kada. So we usually take some liquids ra. Okay, we usually take some liquids. Liquids ante enti? We dip liquids ante enti ra? Liquids ante we dip the objects in liquid. అర్థమైంది? Yes, dip the object in liquid. అంటే if you have a sphere అంటే balloon రా, balloon. Okay, మీ దగ్గర ఒక balloon ఉంటే you try to understand. Okay, if at all you have a spherical balloon, all of you put this balloon under water. When you put this balloon under water, ఏమైతుంది అంటే water will exert uniform force on each and every point of this balloon. అంతే కదా? Yes. Let us say that force is F ra. In case the force is F. Okay, ade. So you can simply say, sir, your volumetric stress is equals to ade, this force F only ra. This force F divided by area. Area of the sphere ante 4 pi r square kada. Yes. Area ante F divided by 4 pi r square. So we talked about deformation. We talked about stress, strain. And strain leads to stress. After that, we talked about types of stress. Moodu types unnai kada. It's not force by volume. It should be force by area only. Okay, area ante surface area 4 pi. Ippudu let us talk about strain andariki. But before that, let me just tell you something about Vedantu All India Score Accelerator Test Series. Okay, andariki jagrataga vinandi. Whoever has not registered for this VISAC test, the first test was supposedly to happen at 4th of January ra. Dan tarvata your second test was at 11th of January and my third test is scheduled on 18th of January and tomorrow itself. All of you have missed, for those who have not registered for the test, you have missed these two tests. Kani, tomorrow's option is there. Windows and portals are open. Okay, you register yourself, only you have a single day test 18th of January and tomorrow. Ela register cheyali sir? This video description section, okay, go to the description section of this video. In the description section of this video, you will find a VISAC registration link. Click that link, register yourself, appear for the test for tomorrow. You will know your score. After this, they will tell you your weak points. Okay? They will tell you your weak points where you can improve material regarding that. Okay, regarding that they will also suggest the lectures to you. Okay, lectures kuda ra. They will also give you the lectures ante recommendations, and then you will be able to accelerate, as the name suggests, score accelerator test ante you will be able to accelerate your score. At the same time, all of you, there is one more gift from our side to you. What is that gift ante either description section lone there are some things ante your first is notes. Biology notes have been updated by Ajay Kumar sir. Physics and chemistry notes have not been updated. I'm working on that thing only. Okay, soon the notes will be available, but you have a very good surprise ante your test series ra. Okay, you have different test series. Physics kosam, chemistry kosam, your biology kosam, ee rendu all of the subject, okay, all of the subjects have test series in your description section. You just click it, you see all the description section, you will see the links. Yeah, when you click it, it will ask you to register yourself. Enter with your email ID లేదా your mobile number. ఒకసారి registration అయిన తర్వాత you will get free access. Okay, all of these they are free of cost. Okay, they are free of cost. So go click on these links. First of all, register yourself. దాని తర్వాత tomorrow is your YSAT test. Appear for that. After this test, you will be getting a lot of material. Start preparing from that also. At the same time, every video ee Super 45 series lone unte each and every video will have description section. In that you will have your notes, and in that you will have your test series. Okay, all the best andariki for this test, and we will come back to our own topic. Ippudu everything is completed about stress. Okay, stress is completed ra. Stress is completed. Jagrataga vinandi. Ippudu we will talk about strain. Okay, strain. Strain. What is strain, sir? Strain is simply, you can say, strain is లేదా strain is equals to deformation. Deformation అంటే ఏంటిరా? Changes. Deformation divided by original configuration. Okay, it's a very simple definition ra. Deformation divided by original configuration. Okay sir, deformation by original configuration ante strain is related to your deformation only. Ide kada? Yes. So sir, what about types of strain now? Ade same ra. What were the types of stress? Are the same types of strain. Okay, so చూసుకోండి types of strain అంటే మూడు types of strain. చెప్పండి, can you tell me types of strain, all of you? Types of strain are three types ra. చెప్పండి. The first type is your longitudinal stress. Okay, longitudinal stress. Next is your volumetric strain. Okay, your volumetric strain. దాని తర్వాత you have your shear strain. Let us see all one by one. Okay, let us see all of them one by one. The first one is your longitudinal stress ra. చూసుకోండి. ఇప్పుడు when it comes to strain, then I can say that strain has nothing to do with your restoring force. Okay, the class will be till 12:30. చూసుకో. So అంటే if this is your rod, జాగ్రత్తగా వినండి. Okay, if this is your rod అందరికి, what you are doing is you are elongating it. అంటే ఇదే మీ deforming force కదా. This is your deforming force F. ఇక్కడ కూడా this is your deforming force F రా. When you applied this deforming force, ఏమైతుంది అంటే the length slightly increases. అదే కదా? Yes. Thus the length increases. Sir, మొదటిగా let us say the length was L0 ra. Okay, L0. In the final situation, the length has increased to L. అందరికి జాగ్రత్తగా వినండి. So the final length is L. చెప్పండి, what did I say? The definition of strain ra. Deformation upon original configuration kada. చెప్పండి, what is the deformation here ra? Increase in the length kada. Yes. So your strain is equals to లేదా your longitudinal strain ra. Okay, your longitudinal strain is equals to your change in length delta L divided by original length L. అంటే L0, sorry, అంటే L minus L naught divided by L naught అంటే L by L naught minus 1. So this is your longitudinal అంతే కదా. yes. Next type చెప్పండి. The next type is your shear strain. Okay. Hey, what is the unit of strain, Ray? I did not talk about unit of strain kada. Yes. So let us talk about unit of strain. What is the unit of strain? The unit of strain is nothing. It's a unitless quantity and a dimensionless quantity. Why, sir? Deformation is the length, original also length. Length by length is nothing, ra. So it is a unitless and a dimensionless quantity, ra. You don't have any unit for your strain. Are you understanding? Yes, change in length divided by original length and there is no unit. Good petkondi, all of you. Okay. Shear stress ante enti ra? Shear strain lo the same thing. If you have a cube, jagrataga, okay? If at all you have a cube, you are applying a force parallel to the surface and this is your surface, ra. Area is A, you are applying the force something like this. So due to this application of force, the shape is getting deformed. How is it deforming, sir? And this is the deformed shape. Ade kada? This is the deformed shape. Okay. So in strain we are comparing the original with the new assembly kada. Ante original configuration and new configuration comparison cheyadaniki, let us take the original configuration, ra. Original configuration was something like this. Ide kada? This was my original configuration, ra. And this slight displacement has happened. This angle theta, ra. This angle theta we will call it as strain. Andariki. Okay? This angle theta we call it as strain. Right? Theta under tan theta, you can simply say that. We usually represent shear strain is equals to whatever the displacement x divided by the height until the length L. So you simply say shear strain is x upon L. Ardhamaindi indiriki? Okay. So this is your shear strain ante displacement x divided by original length L. Are you understanding? Horizontal by vertical. Okay? Right. Now what is the remaining type, ra? What is the remaining type? Cheppandi andariki. What is the remaining type? The remaining type is volumetric strain. Ante kada? Volumetric strain. No, not nothing. Just x upon L. X upon L ante horizontal displacement by vertical length. Ade. Volumetric strain lo, what you're doing is you have initial volume V. Either you are expanding or you are compressing. Ade kada? Yes. So na daggara rendu cases unnai ra. The first case is your expansion. Expansion unte your volume is increasing. Okay? Expansion lo, your volume is increasing. And the second case is your compression. Compression unte your volume is decreasing. Ade kada? Yes. So compression unte this is your volume. In rendu cases lo, I can simply define volumetric strain is equals to cheppandi. I can simply define volumetric strain is equals to delta V upon V. Adera delta V ante enti ra? V final minus V initial. Okay? Delta V ante V final minus V initial divided by V initial. Ade. So if it's a compression unte final volume takwa, initial volume ekwa unte Vf minus Vi become negative and your Vi becomes Vi only ante your strain becomes negative. Are you understanding? Ekkada kuda here also you understand, okay? Even in your longitudinal stress, if you are elongating it, delta L ante L minus L naught. If you are compressing it, your delta L will be negative. Understanding? Right. Next, so with all that being said, right, it's not useful, right? I'm just keeping it. Choose. So let's take 2-3 questions based on it, and then we'll try to go to the next topic. Question is, a rod of length 4 meters is pulled along its length by a force of F is equals to 200 Newton. If the radius of rod is 4 centimeters, okay, and it is elongated by 500 centimeters, 50 centimeters, find normal stress and longitudinal strain. చెప్పండి అందరికి. Do it. Okay, do it. Not radius, length elongates to 50 centimeter. ఓకే చూద్దాం. రాడ్ ఆఫ్ లెంత్ 4 meters కదా. So the length of this rod L is equals to 4 meters, right? Yes. So length of the rod is 4 meter. Force is 200 Newton. And the force must be 200 Newton. And here also the force must be equals to 200 Newton only. Okay? It must be same at all the places, right? Radius is 4 centimeters. So radius R is equals to 4 centimeter. And that means your area must be equals to pi into R square. Sir, pi is pi. R square ante 4 centimeter. It is 0.04 meters kada. You square it directly. You can simply say 16 into 10 to the power minus 4 meters squared. So this is my area. Okay? Your force is 200. Your area is this much. So when you are talking about stress ray, Chapani, when you talk about stress, what stress are we talking about, sir? We are talking about normal stress. What is the value of normal stress, sir? Normal stress is equals to force divided by area. Area is how much, sir? Pi into 16 into 10 to the power minus 4. Ante 2 into 10 to the power 6 divided by 16 pi. Ide kada 2 ones are 2, 2 eights are 16. Under 10 to the power 6 divided by 8 pi. This is your normal stress. All of you. Ardhamandi? This is your normal stress. At the same time, if you want, yes, very good, very good. At the same time, if you want longitudinal strain, kada? Yes. So at the same time, if you want longitudinal strain, Chapandi, longitudinal strain is equals to change in the length divided by original length. Change in length is how much, sir? Elongated by 40 centimeter, 50 centimeter. 50 centimeter ante 0.5 meter divided by original length is 8 meter ante 5 by 40. That is 1 by 8. So this is your strain, longitudinal strain. Ide kada? Yes. Okay. Next. There was a scientist, Hook, okay, Robert Hook. He did some experiments. What experiments did he do? Ante he took a rod, okay? He took a rod, suspended that rod, something like this, and he has attached a mass, okay? He has attached a mass, ante heavier masses. So what's happening, sir? Due to this mass, there is this gravitational force mg acting on this mass, and immediately next to this rod, he attached a scale. Okay, immediately next to this rod, he attached a scale. Okay, yes, so this was the scale, sir. So, okay, this was the scale. What did he do? Choose quantity. For a given length, for a given force, okay, force ante masses, different masses kada. For a given force, he took a table, he took the force. At the same time, he took the elongation, okay, and at the same time, he calculated the stress, okay, stress ante force upon area kada. Yes. And at the same time, he calculated the strain. Jagrataga vinandi, okay. First, he calculated force, elongation in the string, then tarvata your stress, and then your strain. He made a table, okay? He made a quite good table. So he took the values ante stress and strain ki values. He was observing the values of stress versus strain. Okay, anyone is there? Sir, no sir, it's not 0. What are you talking about? Huh? Anyways, so what he did was, okay, all of you, he plotted the values ante different values ochindi kada chuskondi. Here are different values ra, understand? Okay, different values. So what he did is, he made a table, he made a graph. The y-axis of the graph was representing stress, and the x-axis was representing the strain, right? He started plotting the points. Modatiga, where the first points were plotted, each and every point was following a straight line. Okay, ante the length is increasing, strain increasing ante enti ra, delta L increasing ante the length of that rod is increasing. Are you understanding? Yes. So the lengths were increasing, and there came a point at which the points were following absolutely a straight line. Okay, so this point is O and this point is A. So this OA region is known as Hooke's region. Okay, OA region is known as Hooke's region. Dan tarvata, as soon as the values exceeded point A, ante the length exceeded point A, what happened is this linear relationship is not valid. Ante the relationship was coming something like this. Not linear, okay? Not linear. But it came till the point B, okay? Till point B. That means when the length increased to point B, Hooke removed the mass removed chesina tarvata, whatever the extension was there, rod came back to the original position. Ante 100% regain has happened. Ardhamaindi? Yes. Initially there was a straight line. After that, in the region A to B, there was no linear line. Ante the path was a little curved. Are you understanding? Okay. But till point B, okay, till point B, 100% regain was seen. Ante if you release the mass, rod was coming back to the original length. Ante 100% regain till point B. Dan tarvata what happened was, he still kept on increasing the weight, ante he still kept on increasing the length of this rod. Okay, it went to a maximum value. Then there came a point C. After that, then came there a point D. What do we say? This region B to C is your plastic region. Plastic region ante enti? Ee region lo the elongation was happening very fast. Are you understanding? Ante the stress and the strain were increasing randomly, drastically. Okay, and after the point D has crossed, you tell it breaking limit. Ante breaking limit ante enti sir? After this the wire was broken. Ante telsa? Yes. You can also call it to be the neck region. Okay, neck region. But I want you all to focus only in this region, Jagrataga vinandi. Only in this region, okay? Only in this region. This region lo, what you can observe is your stress is directly proportional to your strain, kada? Yes. So sir, in this region, ante Hooke's region, in your Hooke's region, all of you, in your Hooke's region, what can you say is your stress is directly proportional to your strain. Convert it into an equation ante Sir, your stress is equals to some constant K kada. Let us say that constant is E ra. E multiplied by strain ra. Ade kada. So, what do you call this E ray? The value of E is equals to stress divided by strain. Ade kada. And this E is known as coefficient of elasticity. Okay, your E is known as coefficient of elasticity. So, let us discuss something about the coefficient of elasticity. Andariki. Let us discuss something about the coefficient of elasticity. Okay, represented by the letter E, and E is equals to stress divided by strain. So, మూడు రకాల స్ట్రెస్ ఉన్నాయి, మూడు రకాల స్ట్రెయిన్ ఉన్నాయి. సో that means your coefficient of elasticity is also of three types. చూసుకోండి. So types of coefficient of elasticity are three. Number one, when your stress and strain are linear, linear ante normal stress, longitudinal strain. Ide unte you call this value E is nothing but gamma. Gamma ante Young's modulus ra, okay? You call it Young's modulus. Modulus ante coefficient of elasticity. Ade, okay? Second case lo, when your stress is shear stress and your strain is shear strain, you call it as G ante your E becomes G kada, sorry, your E becomes G. E becomes G ante shear modulus, okay, ante shear modulus. And last lo, when it is volumetric stress and volumetric strain, your E becomes beta ante bulk modulus. Okay, I'm sorry, bulk modulus. For volume it is bulk modulus. For shear stress, shear strain, it is shear modulus. For linear stress, linear strain, it is Young's modulus. Chuddam. One by one, let us talk about everything. The first is your Young's modulus. Okay, Young's modulus. Cheppandi andariki. How do we describe Young's modulus? Young's modulus is described with a linear shape. And if this is your rod, if this is your rod, all of you, if this is your rod, area of this rod is A, length of this rod is L, you are applying a force F, okay, you are applying a force F perpendicular to the area. Due to this force F, there is an elongation into the rod. Rod elongate indi, ade kada. Hi, good morning. Hey, it's a good morning also. Now also good morning. Huh? Just so due to this force, there is a little elongation in the rod. Ante we are ready with everything. We are ready to go with your stress also. We are ready to go with your strain also. Limits cheppandi ra. Ante this total length is L. Ikkada nunchi ikkada varaku. Ade kada. Yes. And ee mottam length ante you can simply say L and ide ante delta L. Okay? Are you understanding? Okay, good. Now cheppandi ra. Tell me. Tell me. Young's modulus gamma. Gamma kada, it is nothing but stress upon strain. Stress upon strain. Cheppu andariki. Stress upon strain. What is the value of stress, sir? Stress is nothing but force upon area. What force? Restoring force. What area? Perpendicular to the area. Can you rigid body unte your restoring force equals to your deforming force kada. Deforming force ee question lo icharu kada, it is F. So you can simply say, sir, your force upon area is stress divided by strain ante delta L, change in length divided by original length L. Ade kada. Yes, you simplify it, all of you. Your gamma is equals to F into L divided by A into delta L. You remember, now onwards, whenever you talk about Young's modulus, it is FL by A delta L. Okay? FL by A delta L, FL by A delta L, FL by A delta L. Ade. So this is your Young's modulus. F into L divided by A into delta L. Ade kada? Good. Very good. Very good. Right. Perfect. Now, let us talk something about this Young's modulus only, Ra. Okay, I want to keep my discussion limited up to Young's modulus only. Choose. I don't want to go into the two modulus for now. Good. Sir, na దగ్గర ఒక rod ఉంటుంది అదే కదా? Yes. So let us say, sir, this is my rod. Okay? Let us say this is my rod. Andariki length is L, all of you, and you are applying a force of F on this rod. జాగ్రత్తగా వినండి. Area is A. I'm not concerned about area. కొంచెం సమయం తర్వాత what happened is this length of this rod got increased. Okay? The length of this rod has been elongated. చెప్పండి అందరికి. What is the value? Okay, let us say this value is L only, and this is the extra length delta L that has been observed. Okay, ఇదే your extra length delta L. ఇప్పుడు చెప్పండి అందరికి, what is the formula for Young's modulus? Gamma is equals to F into L divided by A into delta L. అదే కదా? Sir, can I say one thing? Hey, you try to understand. Okay, this A delta L, I'll send it that side and I'll send this L that side. So can I simply say, sir, F is equals to A delta L divided by L multiplied by Young's modulus gamma. Did you understand? Did you understand how did I write it? Did you understand? Chappandi andariki. Did you understand what did I do? I just sent this terminology, okay? This terminology to that side. Ante reverse chesina tarvata I sent it. Did you understand this force? Okay. Rearrange ra. Rearrange ante, can I rearrange it something like this, sir? F is equals to A into gamma divided by L into delta L. Chuskondi. This is my force F. F is equals to A into gamma by L into delta L. ఈ మొత్తం I am calling it some constant, some constant, okay, some constant. Can I say, sir, F is equals to some constant into delta L? Delta L is what? Elongation. Elongation. Delta L is elongation, F is force, and remaining bracket low, everything is constant. You compare it with a spring, you compare it with a spring. Andariki cheppandi. So if this is your spring, sir, you are applying a force F. Jagrataga cheppandi. After some time, what happened is you see an elongation. Okay, you see an elongation. Ante this extra length, you call this extra length as X. Ippudu cheppandi, what will happen? This spring will try to exert a restoring force kada? Yes. So that restoring force is equals to K into X. F is equals to Kx kada? F is equals to Kx. F is equals to Kx ray. X is what? X is what? Extra length. Ekkada chudandi, delta L is what? Delta L is also extra length. Sir, F is what? Restoring force. Ekkada kuda F is what? Restoring force. Here, entire value, it is equal to the K in your spring constant. Ante ee rod, if you are comparing it with a spring, the spring constant of this rod becomes A gamma by L. You are understanding? Okay? Okay? Yep. So, for a rod, the spring constant of a rod is given as A into gamma divided by L. L ante length of the rod. Ardhamaindi? Okay? Yes. Why is it useful, sir? It is useful because, cheppandi, in SHM, in simple harmonic motion, we do have a formula. What is the formula, sir? Formula is, మీ దగ్గర ఒక spring ఉంటే, okay, you are connecting this spring with a block of mass M. Jagrataga vinandi, okay? We will discuss that in simple harmonic motion, but for now, you understand, okay? You understand this. If you push this by a distance x, what will it do is the spring will pull it back. After pulling, the block will come back, it will go again, come back, and back and forth, back and forth, back and forth, SHM. The block will do SHM. Ardhamaindi kada? Okay? What about this block ray? This block is performing SHM. What about time period of SHM, sir? Sir, a time period is given as M is the mass of the block and K is the spring constant of that object. Ade kada? Yes. Yes. Okay? Okay. Right. Perfect. Perfect. So, what did I say? For a rod, you can replace this K with A gamma by L. Adera, you can replace it by A gamma by L. Ante, you do the same experiment, Kani, isari you take a rod with you. Ante, ippudu, this is the rod. Okay, this is the rod. And this is a block of mass M. Chuskondi. What you are doing is, you pull this block with a force F. You pull this block with a force F until the rod will get elongated. And there will be restoring force developed into the rod. A restoring force, what it does is it pulls back. And koncham samayam tarvata the block will come back, it will go to the left, come back, go to the right, come back, go to the left, come back, go to the right, come back, until simple harmonic motion. And time period, sir, are you mad or what, sir? Rod, you are telling it is performing simple harmonic. Yes, it happens. It happens, okay, it happens. Perfect. So you can simply say, sir, time period of rotation is 2 pi root of m divided by k. K value enta, sir? K value we just equated kada, A into gamma by L. Okay? A into gamma divided by length of the rod. Ante the time period of oscillation of the mass is 2 pi root of m into L divided by A into gamma. A ante area of the rod, okay? A is the area of the rod. Jagrata. This was all about your rod as comparison with a spring. Ante enti, sir? If at all I have two different springs, Venandi, okay, this is your first spring. This is your second spring connected to a block. Mass M unte ikkadochi K1, here the spring constant is K2. What you do is you replace these two springs with another spring, okay, with another spring, mass M. Kani the spring constant Kn, 1 by Kn is equals to 1 by K1 plus 1 by K2. Ide kada, ikkada kuda the same thing. Cheppandi andariki. So if at all you have two different rods that are connected, ante ide na first rod, this is my second rod. If I am taking areas also different, okay? If you want, you can take areas to be same, but I am taking areas to be different. And take gamma 1 A1. Here it is gamma 2 A2. Gamma is the Young's modulus. It is given to you in every question, okay? Cheppandi. What did we say, sir? K is equals to gamma into A upon L kada. What is the formula? 1 by K net is equals to 1 by K1 plus 1 by K2. Ante 1 by K net is equals to 1 by K1. Substitute rana. L1 divided by gamma 1 A1 plus L2 divided by gamma 2 A2. You understanding? So when you are replacing these two rods with a single rod, our rod ki spring constant, leda, the rod constant is given as K net, and the formula for that Kn is this. Okay? Right? Perfect. 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 Good. So it was all about your Young's modulus. Now, let us talk about your shear modulus. Okay? Let us talk about your shear modulus. Cheppandi. Second type is your shear modulus. Shear modulus lo, you have your cube placed something like this. It's not required. And what you're doing is you're applying a force. You're applying a force. This is your force, okay? Ide me force ra. Your area is A. After some time, what happens is it will get slightly displaced ra. Ide. Okay? This. Ante sir, if you want to compare it with the original assembly, this was the original assembly. Length is L, distance is X. Cheppandi. Shear modulus. Shear modulus kavali kada G. G is equals to shear stress. Shear stress divided by shear strain. Ade kada? Yes. Shear stress divided by shear strain. Shear stress entara? Shear stress is how much, sir? Force upon area. Force upon area. Ide kada? Shear stress is force upon area. Okay? Shear stress is, Harshita, what are you talking about? I don't know. Okay? Shear stress is me force upon your area, shear strain is your drift లేదా your displacement divided by original length అంటే F into L divided by A into X. So this was all about your shear modulus. Last clue, you have bulk modulus. Okay, bulk modulus చెప్పండి అందరికి. Bulk modulus అంటే ఏంటి సార్? If at all you have a sphere అంటే balloon. Okay, volumetric stress, volumetric strain అదే కదా? Yes. So if at all you are applying a force from all the sides, force is F, radius is R. Okay, initially your volume was V1. After the application of force, my volume has been decreased. Okay, so it is your volume V2 now. Okay, this is your volume V2. చెప్పండి, your bulk modulus is equals to your volumetric stress. అదే కదా, bulk modulus is equals to volumetric stress divided by volumetric strain. ఇదే కదా. Volumetric stress చెప్పండి. What is volumetric stress రా? Volumetric stress is force upon area. Area అంటే surface area కదా. Yes. Divided by volumetric strain is delta V upon V. ఇదే కదా. Yes. This is your bulk modulus. But sir, force upon area, sir, force is from everywhere and area is surface area అంటే pressure. Liquid లో when you are dipping that balloon, you don't say it's a stress, you simply say it's a pressure. And in the liquids and the fluid mechanics, we will be encountering a terminology known as pressure at the depth, rho gh, P naught plus rho gh. Okay, just gurpetkondira for now. This force upon area is known as pressure divided by change in volume divided by volume. So you can simply say, sir, me bulk modulus is equals to pressure into volume divided by delta V. Okay, pressure into volume divided by delta V. If your compression is there, your delta V is negative, so you can simply write minus P into V divided by delta V. If it's an expansion, then your delta V will be positive, Vf minus Vi. Adhe kada? Yes. Okay, yeah, not buoyancy for now. We are not talking about buoyancy for now. Okay, we are not talking about buoyancy for now. We will be talking about buoyancy in your fluid mechanics only. Okay, perfect. Okay. There are two more things left and then tarvata our session will be completed. Hey, what's happening to it? Update ayindi. Oi. Wow, what an update, Sergi. Just visible? It's not visible, Ra. It's not visible at all. Okay. Let us take this. మీకు ఫార్ములా కావాలంటే ఫార్ములా, లేదా if you want the proof, I will give you the proof also. But I want to suggest you to look at the proofs also. Ra. Energy density అంటే ఏంటి రా? Energy density is equals to your total energy per volume. ఇదే కదా. Sir, we are talking about energy density in rod. Ante enti ra? You compare that rod with a spring. So if there is an compression in the spring, half kx square will be the energy stored in that spring. Ade kada. Similarly, if you are compressing a rod, this rod will now develop a restoring force. Ante oka potential energy is getting stored into that rod ra. Ade kada. Yes. So you are storing some potential energy into that rod. that energy per its volume is known as energy density. If you want, you can simply remember the formula. Energy density is half into stress into strain. Okay, not required all these proof. Stress into strain kada? Yes, strain. Are you observing that the handwriting is coming good, right, with this ink? Okay, half into stress into strain. Good. Last topic, last topic is your Poisson's ratio. Hey, what are you talking, sir? Hey, what? Last topic is your Poisson's ratio. Okay, Poisson's ratio. Ante enti, sir? You understand? When we were talking about your normal stress low, did you observe? I had a rod. Andariki chudandi. I had a rod. What did I do, sir? I applied the force F from both the ends, in your normal stress గురించి మాట్లాడుతున్నాం చూసుకోండి. What used to happen, this length would increase కదా? Yes, so this was the length. అంటే increased length. Not like this. This was the length. అంటే increased length. It is become my habit. That's the reason why. FF. But have you ever noticed? Have you ever noticed that when you are increasing the length, volume is constant, volume constant unte, don't you think that the thickness should decrease? You understanding? And the radius of the wire should decrease, so if your initial radius is r, your final radius is also r, and at the same time length also increased. How is it possible, sir? Impossible. You understanding? Yes. And when you are doing that experiment now, you must understand that the radius is also going to change, Yes. So if you are increasing the length, the radius must decrease. Yes. So this would be the actual scenario. Okay? If you are increasing the length, your radius must decrease. Ante the first case or the first observation you are observing is me length ante increase aindi. Okay? Increase in length. And what about the radius, What about radius? Increase in length ante delta L is equals to final length minus initial length. Ante me delta L is the positive quantity. Ide kada? What about radius, Radius is decreasing kada? So there is a decrease in the radius. Okay? Decrease in the radius. So there is a little decrease in the radius ante delta R is equals to RF minus RI. That means your delta R is less than 0 ante your delta R is negative. Ardhamaindi? Right. And your Poisson's ratio, okay? It is usually denoted by the letter sigma. Your Poisson's ratio is nothing but your ratio of change of radius to ratio of change of length of the rod. Okay? What did I say? The ratio of change of radius to the ratio of change of length. When you say the ratio of change of radius, you can also call it lateral. Lateral strain ante negative delta R upon R. Enduku negative, sir? Because radius is decreasing. Radius decrease aina tarvata this delta R is already negative. To balance that negative sign, okay? And here delta L upon L. Ante me sigma value is equals to minus delta R into L divided by R into delta L. Okay, then. So this is your Poisson's ratio. This is your Poisson's ratio. It's 1222 and the chapter is completed. Okay, your entire chapter has been finished. And but before that, let us take some PYQs if possible. Okay, 2-3 PYQs. Okay, 2-3 PYQs. This one, choose. Okay, right. Writing, Sergi. చెప్పండి. Okay, we will take it. We will take it in the next class itself. Okay. Yes, correct. Simple question kada. This is a rod suspended by a weight W. Area is A ra. What do you say, sir? Stress is equals to force upon area. Force is weight only ra, and area is A only. Option D. 2023 loss. Okay? Correct. Okay? ఇప్పుడు చెప్పండి. True. Right. True. Why, sir? Why? Because in physics, it might not seem obvious, sir. Rubber is more elastic. Obviously, sir, it can expand more. Why? There you understand. Physics law work is different than your real life work. Ade kada? Yes. Physics law elasticity ante enti ra? If at all there is this rod, okay, I'm telling you the example of two different rods. Chuskondi. Ide na first rod and this is my second rod. Ante kada? Yes. So what you are doing now is you are pulling this rod with a force F ra. Ikkad nunchi kuda. Ante emaindira? You are deforming this rod. As soon as you have deformed, how quickly the restoring forces are getting developed. That is known as your elasticity. Okay, so if this is your deforming force, okay, but the restoring force, this F restoring has been developed very quick. Okay, and here also it has been developed. Kani, it took some time. So if it has developed quick, what we say? We say it is more elastic. It is more elastic. Your steel rod, you elongate it as soon as you release. It will not even take some microseconds. It will develop the restoring force and come back to original position. Can your rubber low, you release, you pull it, you leave it. It takes some time to develop the restoring forces. Yes. Kabatti, your steel is more elastic than your rubber. Now, whatever doubt you have, you ask me for now, okay? Ledante, we can wind up this session, right? I was telling you that it is for only 2 hours session, so it will be completed in 2 hours only. Chinna chapter. This also, and EM waves kuda. EM waves is also a small chapter, so that will also be completed in 2 hours. Mostly 2 hours or 2.5 hours. Finished. Okay. Let me just send this file to myself. Okay, fine. Andariki, if you don't have any doubts, then we can wind up this session. Okay. And please, for whoever who has not registered for YSAT, go and register it. Okay. Give the YSAT. Dan tarvata, there are some test series also that are mentioned in your description section. You go there also, you attempt all the test series, you attempt all the notes also, you take it from that. And they register chesko. If you're not registered it, you'll not get any note if you're not registering. Okay. Then you attempt for your YSAT test, your score will be given, material will be given, modules will be given. Tomorrow we don't have any class, okay? Your physics and your biology and chemistry teachers are taking the full slot for tomorrow. So Repu is physics holiday. Andariki. Tomorrow is holiday, okay? Tomorrow is holiday for physics. Utilize this time, okay? Perfect. Okay, okay, okay. Bye-bye, 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 all of you. Bye, good night, good night, good night, good night. Good night, all of you. Good night. Good morning is from 3 a.m., 4 a.m. Okay, morning starts from 4. What happened to your sense of understanding? Naku teliyadura. It is 2 p.m. and you are wishing me good evening. Good evening starts at 5 p.m. Good afternoon starts at 12 in the afternoon. Good morning starts at 5 in the morning. Okay, okay, okay. Thank you so much, all of you. Thank you so much. Good night, good night, good night. Bye bye, bye bye, bye bye.